Okay, kids, if you have this worksheet that you were given in a packet, I'm getting ready to work through all 6 of these problems in this video. I've had several questions about gas laws and some confusion, so I'm going to work through these 3 problems. If you want to get that worksheet out, pause the video, get the worksheet out, and work through them with me as I go through them. So number 1, if I have 5.6 liters of a gas in a piston at a pressure of 1.5 atm. Right out of the bat, when you read a gas law problem, you're going to pay attention to units. So first off, you see liters, which is a volume, and then you see ATM, which stands for atmospheric pressure. So ATM is actually a pressure unit. Then the problem asks you to find the new pressure if the gas has been compressed. So I gave lots of insight about Boyle's law and Charles' law and how the actual units play into each other, pressure versus volume, and what kind of relationship that is. So number 1, you're going to write the formula first. P1 V1 equals P2 V2. Now for the most part, how do I know which one's the number 1 and which one's the number 2? The first pressure and volume unit you come to are typically your ones. So you would write those, fill those in first. So this is kind of a plug and chug. So you have 5.6 liters, which is a volume, at a pressure of 1.5 atm. The gas gets compressed until its volume changes to 4.8 liters. What is the new pressure? So you've plugged all your numbers in. Now it's just simple math. You're trying to solve for this P. You need to get P by itself. Whenever you are multiplying in an equation and you want to get rid of something, you have to do the opposite function to get rid of it. So since we are multiplying right here, we need to divide to get rid of that and get P alone. You're trying to get P, you're solving for X. X is your P. Get P by itself. So whatever we do on the right side of the equal sign, we must go to the left side and do the same thing. So now you have simple math, right? But if you're not plugging numbers in your calculator right, you're getting the wrong answer. So I'm going to use my calculator. 1.5 times 5.6. Hit the equal sign in between each step. You must do that or the calculator gets it wrong. Now that answer divided by 4.8. And I get my new pressure is 1.75. Use the same unit. ATM is the pressure unit you started with, so ATM will be your new pressure unit. Okay? So let's ask ourselves a question. This is based on Boyle's law. Boyle's law says that as one of these things goes up, the other will go down. It's called an indirect relationship. If your pressure goes up, your volume should go down. If your volume goes down, your pressure should go up. So let's look at that and see if that holds true for this property. You started out with 5.6 liters. You compressed it. Your volume went down to 4.8. What happened to your pressure? Your pressure went from 1.5 up to 1.75. So that holds true. Your volume went down, which means your pressure should have went up, and it did. So look at number 2. I have added 15 liters of air so 15 liters is my volume to a balloon at sea level, which is 1 atm. If I take the balloon with me to Denver, where the air pressure changes to 0.85 atm, what will the new volume be? So first off, let's look at our numbers. Our pressure went from 1 down to 0.85. So what should happen to our volume? It should go up. Your pressure went down, so your volume should go up. That's an indirect relationship. So if I work this out, I've got to get V by itself. I'm going to divide by 0.85 to get rid of that. Whatever I do on the right side, I have to do over here. Divide by 0.85. Obviously, 15 times 1 is 15. So 15 divided by 0.85. My new volume is 17.6 liters. Your volume units should match. Doesn't matter if they're milliliters or liters. They just need to match the beginning and end of your problem. So our pressure went down. Did our volume go up? Yes. We did a good job. Last one. I've got a car with an internal volume. An internal volume of 12,000 liters. So 12,000 liters. If I drive my car into the river and it implodes, what will be the volume of the gas when the pressure goes from 1 to 1.4? So the pressure in the beginning was 1 atm, and now it's going to go to 1.4 atm. What's going to happen to the volume, right? So now, I've got to divide by 1.4. Divide by 1.4. 1 times 12,000 is 12,000. So 12,000 divided by 1.4. The new volume will be 8,571 liters. Right? Did that hold true for our law? The pressure went from 1 to 1.4, so it went up. Did the volume go down? Yes. So that's a quick review of Boyle's law.